we have given an array of variables, variable pairs, that is called equations, and an array of real numbers, that is called values. And we have given equations at I is a set of ai and bi, right? And values at I represent the equation a of I by b of I, right? And that is equal to values at I. So each ai and bi is a string that represents a single variable, right? Now it is also saying you are also given some queries, where queries at j, let's suppose cj dj, right, represent the jth query, where you must find the answer for these values, right? Means some queries we have given like this. It means we have to do this by this, divide, we have to divide, and we have to find the answer for that, right? Means queries we have to find based on the given equations, right? We have given equations, values we have given, and we have to use that, and then we have to find the value of the queries that we have given. The queries can be multiple because it's also arrays, right? In the array there will be multiple pairs of these ci and ji, and so that at each index we will have two value c and d. We have to divide, and that value we have to find, right? Return the answer to all the queries. If single answer cannot be determined, we have to return -1 by 0. Means wherever the value is not get answered, right, you can represent that value as a -1 by 0, -1.0. And we have to note down that all the inputs are always valid. You cannot assume that there can be a divisor by 0, and that contradiction we cannot result in the value. And so also some variables do not occur in the list of equation that is undefined, so you do not consider like this, so that the division can be good. Like let's suppose if it is 0 by divided by 0, means that can be happen what, arithmetic exception, that called as a, right? So example 1 is saying that we have given inputs, right? So these are inputs we have given. So first input, as the statement was saying, that we have given a array of variable pairs, right? So array of variable pairs is nothing but what, equations, right? And these equations are a pair of variables. So what are the pairs? So a and b having the pair, b and c are the pair. So these pairs, one pair and two pair, right? So this is one pair, this is another pair. So these pairs makes equations, right? And this is the value 2.0 comma 3.0, right? So at index 0, you can see the value we have given 0. At index at index 0 we have given a and b pair. At index 1 we have given b and c of the equations, right? These equations have two index, 0 and 1. Values have two index, 0 and 1, because this should be equal, right? As you can see here, I have represented this. If we do a by b here, because two variables is given, a by b, so we can say a by b is nothing but 2.0, which is in the value, right? As you can see here. Similarly, you can assume b by c is nothing but 3.0, right? Like that you can say. So there is two equations we have given, a by b 2.0, b by c 2.0. Do not see these things, that is not required. I just thought alternative, try to solve that. By b becomes 6, b by a becomes 0.5, a by e becomes minus this, because e is not given, a by a is 1, x by x is nothing but minus b, which is undefined. We'll call add up -1.0, that is given in the note, right? And other than let's understand a by b, b by c, how we are calculating this these queries and these queries, right? So given we have given a query a by b equal to 2.0 and b by c equal to 3.0, right? Means if we have given the equations at the pair, we will divide it and we will assign this value that I was saying here, right? Same thing we are understanding here. Okay, similarly b by c equal to 3.0. And so queries, if we'll divide a by c, and similarly we have to divide all these things, because these are queries there, and the queries we have to represent like this, right? As you can see here. If it is not given, like suppose e we have not given, it is undefined, we will mark it as a -1.1. and similarly x by x we have not given, so it is undefined, we'll say. So undefined thing is nothing but -1.0. a and b was given, right? And another was given, this is the set, right? Another was given b and c, right? Like this. So this is nothing but 2.0, it was coming, and it was in the value section, right? So this was in the equations and this was in the value. So 2.1 2.0 was there, and there was 3.0, right? So at index 0 and this. So what we can represent here is that if we'll do a by b, right? So when we are doing, like going attaching, or you can say doing interconnected the subgraph, so it will become a by b, and so I can represent a by b, and so a by b is nothing but what, 2, right? And when I am connecting with b to c, so this is also a subgraph, interconnected subgraph, and so we can say this will become b by c, and this is nothing but 3, right? As you can see, we have given these equations, and this was the values, right? So based on that, we have to find the queries, right? And for that, the UnionFind data structure we will apply to solve this graph partition problem. And so where we partition a graph into a set of interconnected subgraph, right? So this is called interconnected subgraph, right? And we can represent like this, right? This is for now to understand this one. So if you'll talk about the interconnection, we can represent this like, so if we reverse this, it will become what, b by a. If we'll do b by a, it means it will become what, 1 by 2. Got my point? Similarly, if I'll do c to b connection, it will become what, c by b, and then it will become 1 by 3. So that is called interconnected, right? So here we can say that the nodes of a and c, right, belongs to the same group in the graph, right? Because this is complete a graph, right? This is complete a graph, and we have connected each other. So a and c is connected now, right? So in the graph, right? And so we can say we have to accomplish the first task that we need to perform, and then we have to determine if there exists a path between two nodes. Now we have to understand there is one important task missing, which is how we can calculate the cumulative product along the path. Now we have to understand how we are going to find the problem, right? So there is a call UnionFind data structure, right? I'll say UnionFind data structure. Either use DFS or UnionFind data structure. Okay. So I'm going to do with the UnionFind data structure. Let me know if you need you want to do with the DFS and you wanted to do by the DFS, right? So this is UnionFind data structure. So we have to customize this, right? What we have to do? We will customize UnionFind data structure here. Okay. So as you can see here, the name of UnionFind data structure is originated from the fact that is mainly consists of two operations, right? Union and find. The name suggests, right? So there will be two functions, the union and find. So this find will have a like this find x, right? So this find x will do to get the identity of group that the element x belongs to, which group it belongs to, right? And union will do, as you know that how, if you have seen my last lecture, right? So union we do x and y, or a and b, right? That we have done in the last problem. So when we are doing union, right, then we will merge the two graph, right? So when two groups we will merge it, right? And that the two element belongs to which group, or after the merge, that we can say union. It means simply we will merge these x and y are two are independent, so we will merge if it is not in the same, right? If it is in different, then we will merge. If it is in the same, we will not do, right? So we have two things, the find and union. So we have to customize these two, right? And how we are going to do that, we will see in the code, right? Now let's understand that here how we will do the adaptation, right? Like we will do or more precisely we can say we have a few behavior that our customized UnionFind data structure should process at the end, right? So like let's suppose this UnionFind data structure will contain what it will contain. First of all, we will build a table. Let's suppose we will build a table, and it contains a entry for each node in the graph, right? So whenever we will do entry in the graph, we'll we'll create a table and we'll perform that, right? Like this. So first entry, let's suppose what is the entry, and then the rest of the things we will maintain, right? Means first of all, we will build a table which contains an entry for each node in the graph with the help of UnionFind data structure, right? That we will do. And for that, the entry is defined as, let's suppose there is a key. There will be a key, and then there will be let's suppose we'll say group underscore id, and then there will be a weight, right, like this. So this like we will make the each entry like this, right? So the entry we will define as like this, right? So each entry, you can say each entry will look like this. So it will it is like a key, group id and weight, right? For example, initially we have given a node, right? So its entry is in the table, right? In the table, right? And let's suppose I'll say as a, right? So a indicates the id of the node, right? Id of the node from which what is the node, you can say, right? And then second, a indicates the id of the group also, right? So the node belongs to this id or not, right? Means first of all it will indicate the id of the node, and then it will indicate the id of group that the node belongs to, right? And then finally you can say value 1 indicate the weight of the node, right? So if there is some value, let's suppose a, then we'll say which group id, let's suppose I will pass a for now, and then we'll pass the weight, like this I'm talking, okay? So let's suppose this initially this a belongs to itself, right? Then we can maintain like this, because this is in individual group, right? It belongs to its own graph, right? And then so like this. So initially we will maintain like this, right? So with these definitions the task become very simple, right? Let's suppose we have given two nodes, variable a and b we have given, okay? In that case we have the entries as a group id. How we have here entries a group underscore id, right? And then weight, and b underscore group underscore id, and then weight. These two things. So when a is only one is there, we can write like this, but when we are multiple nodes are there, where single node is there, we will write a. If there is multiple nodes a and b, then we will write like this, right? There will be two nodes. You got my point? So to evaluate the query of a by b, now a by b, right, is what? So how we are going to find a by b? The question was that how we are going to find a by b. So we only need to perform the some calculations, right? Now we have to understand how we are going to find, right, a by b, right? Means we only need to perform two calculations, right? First will be what? A group underscore id equal to b underscore group id. Got my point? Means if we want to evaluate a by b is what, right? It means first we have to find a underscore group id equal to b group id. Means if both group id are same or not. If so, they belong to the same group, that is they exist a path between them. There must be a path between them. You got my point? Otherwise there is another condition also. Let's suppose, so there is a weight, right? A underscore weight, let's suppose a weight by b weight. I'm writing directly a weight and b weight, right? Either will do equal to, or either will do divide, right? Divide of the weight. So if the above condition, the condition first holds, right, then by dividing the relative weights, right, that are assigned to the variable, we then only obtain the result of a by b at the end. So means if this is the condition, we will hold this, right, then only we will evaluate these conditions, right? And then we can say what is the value of a by b at that end, right? Let's understand the example again, right, so that you will understand, right? So let's suppose we have a by b equal to 2, and then b we have b by c equal to 3. This was the example. So initially the entries for each variable should look like where the group ID of each variable is the variable itself, right? And the weight of each variable is 1. I'm repeating again, okay? So the group ID of each variable, let's suppose a, b, c, whatever is there. So group ID of each variable is the variable itself, right? And the weight of each variable is 1. So each variable forms a group on its own, right? So each variable, if the variable group ID is itself and the weight is 1, in that case each variable forms a group of its own, right? Since there is no relationship among them at all, right? Pause it and try to understand. So what I'm trying to say, if let's suppose the variable itself having a, right, and its group ID is itself and its weight is 1, means like this. Again I'm saying, if the variable group ID is itself and the weight is 1. Again I'm saying, if the group is itself, group ID is itself and the weight is 1. So it will look like this, right? Means they are forming individual groups because there is no relationship, no path is there. Now we process the equation a by 2, right? So if we'll do a by 2, if we'll do a by b equal to 2, right? So if we'll process the equation a by b is equal to 2 by joining, means if you'll do union operations, right, the two group that the variable a and b belongs to would obtain a result, right? How we are going to find the result, how we will get the result, how we will obtain the result, right? So we attach the group of dividend a to the one of the divisor b, right? And meanwhile we would also update the relative weight of the group a to reflect the ratio between the two variables. Let's suppose if we have give me one, let me choose the color. I can choose this color, okay? Now think here. Now I will change a little, right? So initially I was talking like this, right? Now it is saying we will attach that group of dividend a to the one of the divisor b, right? Means divisor is what? B, like this. So now it is it will become what? 2, because it is not, its weight is now 2, but its weight is 1 because it's connected with itself, right? And the c is also connected with itself, right? So if we will do like this, then we will connect, right? Similarly what we can do, we can continue the process, the equation b by, I was talking about this one. Now let's suppose talk about b by c, right? What was b by c? B by c was 3, right? So if we'll do the union operation and we group the b and c together, similarly we have attached the group a and b, right? Now the group of we will attach the group of dividend b to one of the divisor, let's suppose c. Here we have given b by c, right, like that. And so we will update the weight of the group b and we will reflect the ratio between the two variables. How we will do that? So now it will become what? A will remain here, it is going to connect with b, it is already connected. Now it will connect with c, but c is having group ID its own, so it will become 1. Now it is connected with what? Previously it have 1, but the incoming is 2, right? It is going this side, right? So it will become what? 3. 1 is coming and 1 is going, itself have 1, right? And the a is having already 2. So the weight will look like this one, right? As we can see here, as we can notice here, this is the you can say some inconsistency in the graph, right? That is group ID of the variable of a should be equal to c. No, should be then b or c. Think. a should be 6, right? It should be, sorry, now we can say that as one might notice that there is some inconsistency in the graph, right? That is, the group id of the variable of a should be c, right? And the weight of the variable a should be 6, right? A should be c and the weight of the variable should be 6 rather than 2. It is coming 2, so it should be 6, right? So indeed these inconsistency are expected, right? The magic happens when we invoke the find operation on the variable, where a chain reaction would be triggered to update the group id and the weight along the chain. Let's suppose what I am talking about. So I can write here, right? Let's suppose we have a here, right? Then we have b here, and then we have c here, right? So now what we will do, we will connect b directly here. So its value is 3, no doubt, no problem. Its value is 1 because it's connected with its own, right? But if we'll connect a to c directly, how it will go? It will connect like this, right? So if it will connect like this, so its weight should be 6. That was expected. That was just saying, right? So previously it was like this, then we b by c is this, but this is called this is we were saying that it is inconsistent, right? And this inconsistency is expected. So when we do like this, then the magic happens, right? So once the lazy evaluation of find is triggered, the states of the nodes along the chain means what? Group, right? Should be updated, and eventually they become consistent. I will repeat. Once the lazy evaluation of the find is triggered, the state of the node along the chain would be updated, and eventually they became consistent, right? So the mechanism of the update is fairly similar with DFS traversal, as one will see more in detail in the implementation later. Okay, so we'll see you in the implementation section, where we will implement two functions, find variable and union find and union, where we'll use find like this. The find will pass a variable, right? And the union will find what there is will be a dividend, then we will have divisor, and then we will have quotient, right? Okay, so let's suppose what is the find variable will be here. So find variable, this function will return the group id that the variable belongs to, and moreover the function will update the state of the variable along the chain. If there is any discrepancy, so it will show you. Okay, let's pause the video for now. So let me clean this, and then we will continue this one. So what I was talking about, see, so we will use union and find method, right? So when we will use find, right, I was talking about, we will pass a variable here, right? And when we are talking about, now we will talk about union, right? So in the union function, we should use dividend, then divisor, quotient will use, right? Okay, so so this function will do what? This function will attach the group dividend to the that of the divisor, right? Divisor, and then if they are not already in the same group, right, in addition it needs to update the weight of the dividend variable accordingly, and so the ratio between the dividend and divisor is irrespectively updated. Okay, once we implement the two functions, then we will solve the problem, right? So we'll solve the problem by two steps, you can say. The first step we will do, we will iterate each input equations, and we will invoke the union functions, these functions, right, on each of them, and in order to build the UnionFind data structure, right. Second, what we will do here, we will evaluate the query one by one, and the evaluation is just a intuitive of our first approach, which can be broken down into some cases. What are the cases will be there? So some cases like either of the variable did not appear in the input, and so we will take minus 1.0 that we have already seen. Then another case will be if both variables are valid, then we will apply the find variable to obtain the, you can say, tuples of group ID and weight ID, right. We will apply find variable, and then we will obtain what, there can be we will get a tuple of group underscore ID and weight. I'm talking about this, okay. This we will do, and then or if they are means if they are in the same, if they are valued and they are in the we can obtain that. If they are not in the same group, right, then no chain of the divisor between them, we will return, we will do minus 1.0 like this. Finally, if both variables are in the same group, then we will simply perform the divisor between them, and then the weight of the we will divide their weights, and so we'll get the result. Okay, it's very easy, guys. If you have not observed till now, pause this video, repeat it again, and so you will have a better understanding. So let's understand the coding part. So now it's time to do some hand study with the code. Okay, so let's understand what I'm trying to say all over the video. Okay, so the question we have saying, based on that we will write some hash map, right. So I'll create a hash map, and we have given you can say equations as we told, right. Then we have values we have given, and the queries we have given. So question was saying this is giving the array, this was also given in the array, and these queries were also given in the array, right. So you can write in the arrays can be written as list of list here, because 2D array we can rewrite like this. Okay, so don't hesitate to ask this question if you are not aware of that. So let's suppose I will write a string. So hash map contains key and value pairs. So I will write, this is the key, so I will write key first here, and then I will write value. So value will be a pair of, right. So what is the pair? So pair is a Java class where we can keep pairs, name suggest, right. So let's suppose how we are writing the pairs. So I will write pair string and double like this, right. And this is nothing but your hash map right now. So I will say gid weight, I will say equal to group id weight, and then we will use new hash map. I will use like this, and I will initialize it. Okay, so if you have any doubt, guys, please ping me in the comment box. Okay, so as I told you, first step we will build the union group, right. So let's build the union groups. Okay, so how we'll build the groups, right. So I'll write a for loop. I will say int I equal to 0, and then I should be less than equations, right. And then we will write size, right. So this is the size function, and then I plus plus. So I will iterate all the size. So first step we have to build the union groups. I'll write here step 1 that I have talked about you. So first step we will build the union groups, means we will iterate through all the equations that we have given, right. So we will iterate it, and then we will iterate through each input equations, and then we will invoke the union function, where we will pass dividend, divisor, and current on each of them in order to build the UnionFind data structure, right. And so that what we will do here, we'll create a list. Let's suppose list of string. We'll get list of string, and then we will write equations, right. So if we have a list of string, that is called equations, we will get from where? Equations, right? So we have given equations at index, right? So this is a list, so I will pass get method, and then we'll get at the index. From each index from 0 to less than the size, we'll go and we'll get one by one from here, right? Once you have the equation, right, equation means equations at I, right? We will get each pair now, and from the pair we can extract the data. How will extract the data? So first of all, we have a string, right? As I told you, the first we will have dividend, right? Dividend equal to equations, sorry, equation, this one dot get, and will pass from the 0. So at index 0 we will extract the dividend. Similarly, we'll write string, this is now divisor equal to, similarly this is at equation dot get at 1, index at 1, 0 we have dividend, divisor at 1, and then we have double quotient, and is a equation dot get no the only two pair is there, a and b, right? Now this is not in the equations, right? We will get from the value, right? And we can write values, this one, right? This one, values at I, we can extract, because it will do a by b. A is dividend and divisor is b, so a by b value is 2, and that we can get from where? The value, right? We can get at the value at I, that index, same index, right? Now what we will do? We'll do union, right? How we'll do the union? Let's not this capital, I will write union function, will write. So we'll create the union function. Let us first of all understand. I will provide the group ID weight, then I will provide dividend, that we have just find dividend, then we have divisor, and then we have quotient, right? Like this, the result you can say. So we will create this union function, and this union function we will create later, right? But one by one will first step we will do, we will build union groups. So with the help of this union function, we will build the union groups. We have iterate one by one all the equations pairs, and then we have iterated. What was the equations pair? Let me tell you. Okay, I'll show you. This is the new way I used to do. Okay, yeah. Okay, so like equations, you know, we have a comma b, then we have b comma c, right? And a by b results was in the values. I think you understand, right? Okay, now in the step 2 we'll move to the step 2. What we will do in the step 2, right? So first of all, we have completed the groups, right? We have built the union groups. Now in the step 2, now in the step 2, what we will do? We will run the evaluation. We will run the evaluation with that we have talk lazy update in find function, right? So we'll run the evaluation with the lazy update in the find function. How we'll do that? See, first of all, we know that we have given the queries, right? So I will write double like this, and then this will make as an array, and this is nothing but our result. So results is an array, and then we'll say new double, and then we'll write queries dot size, queries dot size here, right? Queries dot size we will write, and then this is we will get the result, right? And now we will iterate all the queries, right? So we should write int I is will start from the 0, and then I should be less than queries dot its size, right? And then we'll say I plus plus, right? So we have written a loop of we will get all the queries, right? And then we will get one queries at a time, right? So let's suppose list of string, will say list of string that contains one query at a time. So one query, single query we can get from what? We have queries at what? Index I. At index I we will get, right? So one by one we will get all the queries here, right? We are iterating, and then we can find similarly that we have did, we will get dividend is nothing but query at query dot get at 0, right? So we have the in equations we have the pairs of variables, but here we have the result. So from the result we'll extract like this, right? Now similarly we'll find the divisor. We'll have the string divisor, and we can get from where? Query. So we have this query. From the query we will say get at 1. Both we will get now. Now it's very important to understand that the group ID weight, if it contains the dividend, right, and group ID weight if contains dividend, right, it means then we have to calculate. If it doesn't contains, means these are undefined, right? And then we will assign result at I is nothing but minus 1.0, right? That we have seen, right? So this is very simple, right? So we'll write if condition, and we'll say not gid weight dot contains key, and the key is what? Dividend. We have the dividend, right? This dividend we will pass here. Got my point? So if the gid weight group ID weight contains key dividend, right, then we will continue. We will find divisor also. If divisor and dividend are available, right, in that case we will continue and will find the result. If if it is not available, dividend and divisor is not available, right, in that case what we will do? We will assign the value minus 1.0, right? And for that we'll do similarly not gid weight dot contains key, and the key is not what is this? Divisor, right? Like this. And in this case what we should do? Divisor, right? And in this case what we should do? We will assign result at I is nothing but minus 1.0. This, right? We have this result and we will store this result value here, right? Now if it is available, then what we will do? We'll make else condition and then we will calculate. So first of all what we should do? we will find dividend entry, right, and divisor entry, right, and from there because we have to find we will call the find function, and then we will get these two value, right. So let's suppose what I'm trying to find, let's suppose we will create a pair, right. So pair of string and double will create, so that we can say the name dividend entry. So dividend entry we can get from where? The find function, right. So the find function we will pass, and then we will find get weight, and then we'll find dividend, right. Two things we will pass and we'll get. Similarly, we'll find this we'll create this find function, union function and find function will create. Similarly, I will write for divisor I will write, and this is not what? Divisor. So we will have divisor entry and dividend entry we have. Now once you have union and find, right, created, then what we have to do? We have to extract the values. How we'll find the extract the value? We'll write a string, and then we'll say dividend and gid. Dividend gid is we can say from the dividend entry, dot we'll do get key, we can extract. Similarly, we can find double, right, double dividend weight equal to dividend entry dot get value, this one, right, that we will extract. Similarly we'll extract the two other things from the divisor. So let me change divisor. I will write minimal changes I will do. This is also nothing but divisor, right, and then this is also divisor. So we have extracted this value because these values are required, right. Once you extracted the dividend entry and divisor entry, you can have the dividend group ID, divisor group ID, then dividend weight and divisor weight, everything you will have. Then what we should do? We should check these values, right. How we are going to check this value? We'll check if this value, if not available, right, dividend that we have found, dividend group ID is equal to divisor group ID, GID. If it is equals, right, divisor group ID and dividend group ID is not equal, right, in that case what we should do, right, means we will have case 2 that we have talked about, right. What was the case 2? So I was saying case 2, the variable do not belongs to the same group or chain, right. So let me write the variable do not belongs to the same chain, yeah, group. When I was talking about the group, right, or chain, it means same. So we'll find like this, right. Now what we will do, if it is not belongs to the same group, right, and the variable do not belongs to group or chain, you can say, in that case we will assign similarly that we have already earlier done, that condition will assign, that is what, minus 1.0. okay. If results, that was, it is giving the error, okay, like this. If else, if it is done else, in the else condition what we will do, okay. So you can remove this, it is not required, or let me remove from here else. In the else, let's suppose we have that we have talked about case 3, right? So there is a chain or path, right? If there is a chain, or you can say group, right? Or path, right? Path, there is chain, group, or path, or chain or path you can write. Confuse, don't confuse between yourself, between the variables that I have shown you on the slide, right? So what we will do, we will have the result at I, results at I. How we are going to calculate? We will divide the weight, dividend weight, we will have, right? And then we will have divisor weight, this one. Then you will get, once these are done, right? Once these two are done, we will return here the result, right? Return results, right? Now very simple two things. See, only there is problem. This is very simple problem, right? What we have to done, we have to build the union groups, and then we will run the evaluation of the lazy updates, and we will extract the values. And once we have extracted the values, then what we will do, we'll check the conditions. If both are not in the same group or chain, there is no path, we'll assign -1.0, because in the note it has said that if it is not contains, it not belongs to any group, assign the value -1.0, or if it is undefined. Otherwise, if there is a chain between the variables, you divide the weights and then assign the value, right? Now we have to write these two functions, because these two functions is giving error, union and find, right? Line number 11 and line number 23, 24. Okay, so for that we'll come here in these sections, right? So let's suppose we'll create the find function where we have to pass gid weight and dividend, right? Means first we'll pass the hash map, another will pass dividend, is nothing but a pair, right? How we'll going to write here? Let's say I will write because it's a utility method, I will write private pair, and then I will write string, and this will be your double. Yeah. Okay, like this. I will say this find, and this is your hash map, right? And this hash map will contain string and then on the pair, right? Pair of what? String, pair of it should be string and double, right? String and double. Hash map, yeah, one more. Okay, and then this is called what? Weight. We'll say weight, group ID weight, right? And then we'll pass the node ID. This is nothing but node ID. So whenever we are passing, this is node value ID, divisor is that value, or you can say variables, node variables also. I will say node ID. Okay, if you pass the node ID, because the group, the variable itself, node itself going to having the independent group ID, right? And so independent group ID, the node group ID, individual group ID is called node ID, or you can, for now you can also write variables. Okay, so now what we should write, we should check the group ID weight and node ID weight is not equal, then we will put, right, otherwise we'll find the value, right? So if not group id weight, right, is contains key, right, we can write contains key and then wait node id value, right, node id. If it is not in the sense, we will put in the gid git weight, then we'll do put and then we'll pass node id, we first will add and then we'll assign a new pair of key value pair. Key is what, pair is key, and key is nothing but your string, right? I will write string and another will be double, right, double, right. Oh sorry, this should be the type, right, value is already there, so we should not write, we can directly write here. So there is a node id and default value I will assign 1.0 default value, right, like this, one way, right. And then if this is the condition, then we'll create a pair string and then double, right. So if there is a pair that is called entry, so entry equal to gid weight dot get, if it is available, if it is not available then we will put, if it is not available then we can get from the gid weight, right, all the weights in this gid map, right. So we can get from here using the get method, we'll pass the node value and node id value and it will return you value. So if we found inconsistency that we are talking about, let's suppose we found inconsistency, right, that I have talked about, then we will use trigger chain update, then we will use what, trigger chain update, and we'll check if not entry dot get key dot equals, and then we'll pass what, node id, like this, right. Then what we will write here, we'll write a pair, right, we'll create a new entry as a pair of what, string and then double, and this is nothing but new entry equal to find gid weight and then entry dot get key, right. So if there is a inconsistency, you can write like this, right, you can provide like you can find the if there is inconsistency means the key is not equal to the node id, right, we have found but it is not equal, right, key is not equal to the node id, right, you have got the key but key is not equal to that, means there is an inconsistency, right. Then we will find through the key, and then we will put it again, right. How will put it again, so we have this one value, right, so we'll add here, okay. So here we'll write gid weight put, at the place of gid we are using this new key, so we'll use this new key, and then I will write new pair like this, and here will I write again new key entry like this, right. This is your new entry, we will put this value new entry dot key will write, and then we'll get this value, right. You got my point, you get the value, you have got the entry, or you can write this new entry, you can get, or yes. So here when we are writing this value, right, so we'll write you can write this, no, this id should not change actually, yeah, this id should not change because this id we have to put, only we will update the value, right? So we have already the new entry we already have here. We get the new entry, and then we'll say, and just write new entry here, new entry. Will new entry dot get key we will write, and we'll do multiply, let's suppose, right? With the, or what we can also say, entry key, entry dot get key, and then we will write multiply. Yes, we can write multiply. Why? Because entry was already there, right? So that value we can get, right? So not key, we can say value, right? Am I writing right or not? Let me think, guys, 1 minute. So we will have a node id, that is fine, as a key. Now we'll have a new pair. I will use a new entry. Yeah, keep it as a new entry that I have written, right? New, sorry guys, let me write here again. So this I will remove. New entry dot get value will do get key, for now get key, and then this is your, we have put, then we have created a new pair, new key we will write, and then we should write at the value here, this value actually changing, right? So there should be value, right? So we'll write entry dot get value, and then we will multiply new entry. Yes, because that is fine, right? Entry dot get value. See why I'm confused here, because we have already find, right? If we have find, then we have the data, right? And the entry is available here. But if it is found inconsistent, right, means we have to trigger the chain, we have to update it, right? How we'll trigger it? We'll find is this value is not equal, then we'll find the new entry, right? We have the entry get wait, we have and new entry, then get key will do, we'll find the new entry. The key will be the same, because at this id we have to update, and then new pair will get the key will be the new one, but the value that we were putting here, it will be the entry value, and the new entry value will do multiply, and that is the value will come, that is we will store on the git wait, right? Git wait we will update here. Once this is done, guys, then we will return git wait here, and then we'll say get in the key, what we will pass, node id. Yeah, node id, right? Node id is individual group id, or you can write variable also, right? So you will return this, and node value, right? It should get the value. Yes, fine. Okay, it was compiling maybe in the background. Once this is done, you will write the you can say union function. How will write the union function? I will write like private, then we can write void and the union, and then we'll write has map, then we'll write string has map string, and then there will be a pair, and this pair will contain string and double. For now you have understood now, and then this is called git wait, and then we'll pass what, string dividend string divisor and double values, right, like this. So once all are available here, right, once these are available, then you can start writing the code, right? So how we are going to write, let's see. So first of all we have to do union, and union at the time of union, let's see, yeah, we are passing the double quotient and then values, right? We are passing, okay. You can write this here also, value is in the double, right? Let's check. Yes, it is in the double. Okay guys, I don't want to confuse you, that is why I am checking. I can write the code, but you should not be confused. Okay, now we have this union function, right? Now similar to here, right? We have to find, you can say, you have to use these functions, right? You can use this, or I can copy this part of code here till here, right? We can copy this part of code because we need dividend entry, divisor entry, and the its values we require this. So I'll copy this, I will write here. Okay, give me 1 second. Okay, so I will have all these value that is required, right? Means we have find dividend entry, divisor entry, and then the dividend GID, dividend weight, divisor GID, and divisor weight. So all the group ID and weights we have now. Now what we should do, we'll check if we want to merge it or not, right? To merge this, what we have to check, right? So let's suppose I will say we will merge the two groups together by attaching the dividend group to the one of divisor, right? One of the divisor. Yes, we will merge the two group together by attaching the dividend group to the one of the divisor, right? And so let's suppose what I'm trying to say, we'll make a condition first, and we'll say if not dividend GID is not equals, means group ID are not equals to what? Divisor, right? If it is not equal to divisor group ID, right? If it is not equal to group divisor ID, right? In that case, give me 1 second, I did typo. In that case, what we should do, think, we will put this, we will merge this, you can say, right? How will merge this? GID, we have bit, we'll do put as we have done earlier, and then we pass dividend group ID, and then in this group ID we'll assign new pair, and this pair is nothing but string and double, and the value will be in divisor GID, right? And divisor weight, and the divisor weight we will multiply with the value, or you can say quotient that we have found, and we'll divide by dividend weight we should take, and dividend weight, this one, right? Now it is in the, it is merged, we have merged the, if it is not this, right, then we will put into this, right? And so we have done, we have merged this together by attaching this, right? Now let's suppose about the time complexity, guys, right? So what is the time complexity, right? So time complexity, if there will be m operations, right, either on by the union function that we have created here, right, or the find function right here, either we'll use this function and this function, right? So if there are m operations, that operations are either union or find. If we will apply to n elements, right, so total time complexity will become what in the union find? O of m dot log n, right? If there is m operations, or you can write in the capital, because in the textbook we used to read like this, right? And so if there will be m operations, and those operations are either union and find on the n elements, so the time complexity will become o m dot log n, right? But let's suppose n be the number of input equations here, right? Total number of equations are n, and m be the number of queries, right? What I'm saying, let's suppose n is number of operations, right? N is number of operations, number of input equations, right? Equations like this, and m will be the number of queries that we have, right? How many queries we require, right? Number of queries. Then we have to update the time complexity. What will the time complexity, guys? Now TC will be get updated. How will update it? It will become, because we have m plus n, right? So I will write, let's suppose m plus n. This we will do dot log n. So in general cases, what is happening, if m is the number of operations and n is the number of element, then we'll write like this. But in our cases, we have n is the number of equations we have given, but m is the number of queries. It is not one. If it is one queries we have given, then it is fine. But is number of m queries we have given, m plus n we will write. If we'll talk about the time complexity, guys, so you can say space complexity, sorry. So space complexity for the union is O of n, and time complexity of the find is O of n, and so that this will say a space complexity is O of n. O of n. So O of n plus O of n is O of n. O of n for the union, and O of n is for find. So if you'll say, sir, I have also used the has map and those things, right? So we do not take any extra spaces, because other than this, because the space complexity that we have used, right, is auxiliary space, and that can be ignored in Java, right? But we did not take into account the space because it needed for hold the result, right? And if that we will count, so in that case it will become O of n plus m, but you should say O of n. So total time complexity.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel. Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel.